It's not authentic. It's not authentic.
Have you seen those?
I mean, shaders aren't authentic.
That sounds like whoa.
Have you seen those?
Pixel art game?
No.
Have you seen those
Oh, they're
videos?
not authentic pixels.
Yeah.
I forgot what it's called. It's this one game where he plays a raccoon, where I think he posted before and after pictures of his pixel art game for like before he added shaders to like all the sprites. Where it's very basic, but now it looks like high definition.
Alright. Stream is up.
It's up?
I think it was that extension.
Really?
So,
That sucks.
yeah.
Are you excited for GDC?
What's up, dude?
Really excited. Yeah.
Hi, Jake.
Less excited as I was last
Nice
week.
meeting you.
I wasn't actually planning on going this
Good
year.
to see you.
Good to see pizza again.
I was not going to pay.
Are you attending this meetup?
No, I'm just doing pizza. No.
I was going to say no.
We probably have enough either way.
Yeah. Yeah. I didn't bring anything to work on.
Are you doing training?
It's okay. Well, we're going to be talking about. Well, he's going to be talking about shader graph.
It was a lot of
That's
fun.
why.
But
Well,
it was a lot of time to
see everybody.
because it is and then we get there Sunday.
Oh, we're doing it out here, huh?
Yeah.
Okay, cool. Great.
Just 10 nights
Just
of
do
fun.
Train Jam, GDC, PAX.
Oh man, that would be SXSW. Yeah. No. It's too much. The stream is going. Don't say anything too incriminating.
Unity sucks.
Whoa.
Okay.
Zach loves crying.
So what new engine are you working on now, Zach?
You're making a new engine? Again?
No. I'm still waiting for the release of Jonathan Blow's language before I write my own.
Is there any updates on that?
He's working.
I mean, the update is he's going to take longer.
Right. Well, he's doing streams of it, but of him making a game using the language. So
I pretty much watch every single one of his streams.
Do you?
And by watch, I mean I have it on in the background while I do other stuff. But, you know, there was supposed to be a private beta release last year, but it got postponed to this year, and it still hasn't happened yet, so.
I'm not sure if I heard wrong. Is he making it or is he hiring somebody else to make it?
Both. Yeah, he has his own company, well, which he's had for a while, and he's basically got 3 people working on it, including himself.
Does his company have his last name in it?
Blowfish Studios?
Blowcut.
What is his studio?
Thekla Inc.
That's it.
What is it?
Thekla. Thekla. He used to have a company called Number None, and then for The Witness, he made a new company.
The Witness was good. That company name kind of sucks though.
I just watched that, I think it was a 40-minute video saying like, here's why, you should play The Witness, but here's why you shouldn't though.
Here's why you shouldn't.
No, it's like, I think he described it like the greatest game you shouldn't play.
What?
I mean, if you get spoiled on The Witness, it removes like half of the awesomeness.
If you do what?
Get spoiled on The Witness.
Oh yeah. If you know how to solve any of the puzzles beforehand. I didn't, so I thought it was a really good game.
Because then it's like, it's mind blowing. But if you know ahead of time.
Was that a pun?
Yes.
I just hated the sound puzzles. It was terrible.
I
Oh, yeah.
hated the color puzzles
I had issues with that too.
because I'm
Colorblind.
colorblind.
There was no color line
What's
one?
up, Ben?
No.
Wasn't there this one
Yeah,
where
you
like
don't-
you had to watch like a 40-minute video?
No, thanks.
Where you staying at?
That's what one of the guys like
Mom's
keep
house.
complaining about. It's a great game.
Sounds made up, but it's
100% it. It's more like why you should 100% it.
Oh, okay.
It's like some of the puzzles are just insane.
I almost thought at first you said my friend Mom's house.
My friend Mom.
Yeah.
You don't have a friend Mom?
Nope.
Because like I think the puzzle starts where
It just seems like a shorter way
there's
to say
a
my
projector
friend's
screen
mom's
and like
house. My
there's
friend
like a
Mom.
white path at the very start of the video that you can follow. And then you have to hold it till the end of the video till you like the rest of the path appears. And apparently it's like 40 minutes long.
Oh, I could see that.
You'd think
There,
that-
like the underground section thing there.
So the majority of gamers are.
It's like a projector on the wall.
Yeah.
And
I know, this pizza, they did not cut it well.
it's a high percentage.
Anybody else experience that?
I got a 4.
Lazy cutters.
Basically, Jonathan's flow is not the best
Nope.
person. And he's one of those people that goes, my creative vision is more important than colorblind people.
Oh yeah, the sound one, I had to look up how to do it because I was playing without volume.
Well, so I was able to get through quite a few of the bird chirping ones. The maze thing ticked me off though, because I was playing muted because I was playing right at that.
Yep, I was also playing without sound.
That ticked. I bet
I
spent
guessed
2
one of
hours.
the, I guessed one of them just like
Really? Like,
by accident.
I tried to brute force it, and I still couldn't get it.
Yeah, I must have just got really lucky.
I was like looking at like the edging of the grass and
Yeah.
the shrubs. And I was like, oh.
Yeah, that's
Right.
anti-accessibility right there.
Yeah.
Is it bad I only know who Jonathan Blow is because of the movie?
It's okay.
No.
Like, maybe if like a witness gave a conversation with like who he was, but wrong time only knew him because of that one guy.
He stole my name.
I saw that locally source is sharing our streams now,
Mm-hmm.
our meetups.
So how's everything?
Yeah, they're
Good.
starting to pick up on that. It's really cool.
It's good. I feel like, well, I've only actually been doing it.
Is design thing still
I
a
had, like,
thing? I haven't heard
a week
much
right
about
nothing
The
but,
what?
it. Design?
The logo?
buy furniture
Like
and stuff.
the articles and stuff.
No,
Oh, design.
I can't possibly
Right.
do that.
I don't know. I haven't heard.
My brain won't let me do that.
Are you
Just like in a constant state of like anxiety because I feel like I need to do stuff. Yeah.
Yeah. That's good. Are you looking at your brother out?
Mhm. Yeah. So I'm renting my condo out here, furnished. So I had to buy all my furniture. Yeah, put it all together.
Right now. Yeah, that's good.
Did you go to IKEA?
I did. I went to IKEA probably 5 or 6 times.
Yeah, with it right there. It's convenient.
Yeah. But I forgot how long it takes to assemble their furniture. Like it took a really long time.
I mean, the instructions are nice if they're like just, pictures, but you still gotta be like,
Yeah.
make sense of the picture and then you get it right.
Yeah.
Yeah, but the beautiful thing there is you can always take the furniture down.
I'm not disassembling my furniture.
It's not even worth it when it's that cheap.
Will it actually come apart like good? Probably not.
No.
Like all the
Some
little,
of them
mats.
It'll
some
come
of
apart
them
like that pizza there.
Yeah. Yeah, it will go. Yeah.
Just don't get your furniture from Walmart. I did that for my apartment. I got a few things from it, and I think some of them I haven't even had longer than 6 months, and they already started breaking.
What are you doing to that furniture, Jay?
This is on camera, man.
Yeah. Everything. Yeah, forget about it.
No, I do use like I forgot flex glue. I use flex glue to fix.
Flex glue.
Yeah. So you know flex
Is
tape?
it like Flex Seal?
Yeah, but it's like
Same for
It's
brand
glue.
one.
It's like Gorilla Glue.
yeah, but except it's like rubber cement.
So it's like cow glue. Horse glue.
I don't know as many glues as you do, but
I'm just saying animal glue.
Good stuff is the armadillo.
Yeah, that is the good stuff. Rolls up into a ball.
I have to think if Garrett was joking there or not.
He's joking. That was joke, Garrett.
Was it?
I guess I'll stop storming.
Hang on, I'm gonna get some water real quick. We got a full minute still.
That's right.
Oh yeah.
Now it's time.
Smaller room today. I just saw that showing up for the most part.
So far.
People might just be late.
Mm-hmm. Kevin is watching on the stream.
Right now?
I think so.
Oh, no.
And then,
Assuming with the person on the Discord that said he was like, "Oh, I'm getting sick, so I'm not going to show up."
yeah, that was Kevin.
Do most people tend to, I guess RSVP to the meetup?
So I figured day of 75% of the people that are going to RSVP have. So day of, like 4 to 5 will end up RSVPing, and then of those, 1 at least won't show, and then at least 1 to 2 will show up without having RSVP. But even that can vary widely. But that's like the average. Yeah.
Like if I see the post, I'll RSVP, but I admit I can't.
And then you have to take
have it.
Oh, sorry. Go ahead.
No, I was done.
Oh. Yeah, and then you have to take into account the dumbasses that eat before they get here too,
Yep.
like me.
Lose it.
I still had a couple. Probably shouldn't have, but I did. All right.
I imagine we have leftovers.
Ready to go for it?
All right.
Don't forget your introduction.
My introduction?
Yeah, because nobody knows who you are.
Oh
Who
yeah.
dat?
Who are you?
Who this boy?
All right. I am, as you guys know, Jacob Biemers. I am a hobbyist developer from Grand Rapids. For the people here at the meetup, you guys already know that. But today I'll be giving a short run through of Unity shader graphs and why you should use it, and why it's, in my opinion, the best preview package that Unity currently has out right now. So yeah, you can follow me on social media at JakeIsDev. That's my moniker for pretty much everything. Quick shout out to the game dev Discord. If you guys haven't joined already, you have a link down. Just go to gamedevmi.com. So I just want to feel the room. Who here knows about Unity shader graphs? Okay. So for the guys who don't know, it's one of the preview packages that Unity came out with early last year. They came out with, especially in the last year or 2 years really, they came out with a lot of preview packages, including like they acquired ProBuilder and ProGrids, added that to their preview packages. They're betas that you can sign up for, or rather download at your whim. But so yeah, like shader graphs is also, it came out with their new lightweight and high definition render pipelines, which I'll go over later in the presentation. So as you can see here, shader graphs will allow you, is a node-based solution that allows you to create shaders without the use of scripting. So beforehand, you had to like pretty much write all your shaders by hand. There's a lot of this complicated code that even a lot of programmers didn't really understand, because it's something like, as you can see, visual as this, except that you need to write all by code. So right here's a few different examples of different shaders that were made with the shader graph system. As you can see, it allows for like different effects on lighting, as well as some really cool unlit solutions like here. And a lot of these were done by masking, so you can look straight through it or have a holographic projection. There's a lot of different ways you can customize this. Like as I said, basically instead of deciding how something looks like by writing out scripts, you get to see it all right in front of you. Or more accurately, this. I admit, before shader graphs, I only done shaders one time and hated it, and I was like, okay, I'm never going to do this again. I'd rather go in the store and try to like find a paid version of the shader I want to get, because it was just something that was like very hard to understand, and especially if you're not familiar with how 3D graphics are programmed, you're not sure how rendering is programmed as well. It can be very difficult. So yeah.
Do you use that outside of Unity to like export the shader file?
I don't believe it will be compatible, no.
The shader graph stuff technically compiles down into Unity's own shader language, which is similar to HLSL, but it's still custom, and they've got macros and things like that.
Like,
So would you be able to use it with? Okay, with this, don't you need to use like the lightweight render pipeline, or don't you use one of those pipelines for this?
Yes. I'll be talking about the installation of it.
We can get to that part later, but
Yes.
You were saying it spits out a script.
It does.
Can you use that script without render pipeline?
If you were to set up all of the rendering inputs, in theory, yes.
Okay.
But
Yeah.
it would require quite a bit of commitment to really do that, but you might be able to cut and paste some of
Okay.
it.
Yeah.
But let them keep
Cool.
going.
Continue.
Why you don't
Yeah.
need to do that.
And to further ask question using outside Unity, like again, you can't really bring it out because of how it's compiled, but if you're knowledgeable in this stuff, you can follow the logic really, but that'd be, I think even more difficult. But so there's a lot of different benefits for using the system, as may I even please say yeah, but yes, it's all visual. You get visually you can see how it's changing. A lot of it I really like is that with writing your own shaders, you only get to see like the final output as you work on it. The whole time you're seeing like, if I did here, here's what final outcome is. It also allows you to see the variables. So you're saying like you want to create like a different gradients or different masks. You can see what those look like in real time without seeing how it already affects the final product, which is really helpful. Of course, doing this, it saves time, and also there's no programming knowledge needed. However, if you have that knowledge beforehand, especially with the math that's involved with this, it will help you out a lot. It's also preferred that if you want to go into for example, a technical artist, they're in high demand right now, and if you were able to have the technical knowledge and the artistry behind it, it's a well-paying field to get into, right? I'll look to you guys for approval.
It's on par with an engine dev.
Okay.
There is a lack of like technical artists in the industry, also like raters versus animators.
Mhm.
Nobody wants to do rating because it sucks.
Yeah.
There's no glory in it either.
I feel like if
Oh, what did you do in this game? I hooked bones up to matches.
And then I
Yeah.
sat there and I weight painted all the models.
yeah, I have an issue with that. Like if I showed you anything I think I've ever modeled and tried rigging myself, it looks very janky. Especially I tried this making this one game where I would have like customizable different clothes. So I kind of like, it's probably not how you're supposed to do it, but like modeled it over almost. And the second I tried like getting it to work with the mesh as well. Second you have like fully closed shirt, but the second you do this, it'll start like Z fighting. You like naked for like half your run, go back through your clothes, and like it was bad.
Might be good depending on the type of game you're making.
It wasn't that type of game. My family sees my games. And if you ever use, I haven't personally too much, but you ever use any visual scripting solutions, the node-based system will feel very familiar to you firsthand. So we're going to move on here. And I'll like to just quickly give out some two terms just in case for anyone who's unfamiliar with what we're talking about today. A shader. A shader is a program that describes how a color is interpreted by your computer. It's basically the directions of how this pixel on your computer is going to be rendered. It can be affected by the lighting in your scene, or it cannot. It'll be unlit. It can be affected by how the vertex is interpreted. How oh no, my notes show up on here. Oh yeah, lighting and how like different textures and inputs you put into it are affected. There we go. So this would be an example of
Like the Hope one.
what was that?
The Hope one.
Which one? The Hope.
The Obama one.
I didn't even realize that one. Okay. Does anyone remember what this monkey's called? I forgot. It's the Blender default one.
No.
Forgot the name. Okay. So this would be an example of different ways that the shader graphs can be interpreted in a way that affecting lighting, affecting how textures are rendered. You can also do it based on different positions of where the camera and lighting is in your scene. So this one will probably be like unlit, and then it takes the texture and just has it based on the camera position, just project it wherever it is. Doesn't really care about the depth of it. And yeah. So a lot of this is really good because beforehand, if you didn't have that shader knowledge, you're kind of stuck with the standard shaders and how basic render could be. With having the shader graph and maybe a limited shader programming knowledge, you can easily have results in a more stylized format and make your game look way better. Node in this, it's pretty much I like to think of it as like a highway with different like pit stops. It's how be able to handle the traffic and go to different pit stops, different nodes that will change how it's all interpreted. So if we go down here, we have like different colors and gradients. and all this will go to like see the screen position right here. We go into tiling and offset, and it'll just help interpret and change how change the information, bring it in till you get to what the final product will be over here. Again, it can be very complicated to see this some of this up front, but when we break it down, it will help simplify things. So as Brett mentioned earlier, there is some installation requirements. It was brought into like Unity version 2018.1. So if you're holding on to getting into like 2017, 2018 because you're still using JavaScript or even BoostScript, you had to make this jump to use these.
Is anybody doing that? You are?
No, I did that though.
Oh.
I used JavaScript with Unity, which was probably not a good idea.
You mean Unity script?
Unity script, yeah. But it's because like I had that I used to do my first experience in programming was like a teacher telling me to look into like HTML, CSS, and learn JavaScript that way. And
I did the same thing when I started.
Yeah, went to Unity. I was like, oh, it has JavaScript. I have that knowledge, but
it's typed, so it's not really JavaScript.
Oh, it is types?
It's typed, yeah. It's typed sort of like ActionScript would be, where you have colon and then you say the type afterwards.
yeah, and it's just converted
Yeah,
to
or
C#
TypeScript.
behind the scenes.
Or that's the more obvious way.
Yeah.
I was
Then
just about to ask.
whatever Unity script you have, it was just being converted to C# anyway, and like I think Unity technology is like, why are we doing this?
Yeah.
But I feel like if you had a decent grasp of Unity JavaScript within Unity and you were made to switch to C#, it's pretty easy.
not that much.
It's just small syntax changes within a couple of days. I was kind of scared about moving to a whole new language, but within a couple of days I was like, okay, you just got to do struct updates and that's it. So you need Unity 2018.1 and or above. Within soon release, they'll soon release when it isn't a preview package where you just load up Unity, it will be there from what I've been reading. But for now, you either need to do the lightweight render pipeline or the HD render pipeline, as well as the render pipeline's core, which you'll need for lightweight or HD anyway. And of course, shader graphs as well.
The biggest difference is there, the
Yeah.
lightweight render pipeline, when you're doing shader graph, you'll have fewer output nodes because the lightweight render pipeline is board render only. There is no deferred render, whereas the HD does, so there will be more output nodes available. So if you're following tutorials or anything you're missing, it's because you're on one or the other.
Okay.
Also, lightweight render pipeline breaks a lot of assets you might buy.
Yeah. For example, like assets you can't use for lightweight render pipeline, I learned as the hard way, you can't use their post-processing pack with a lightweight render pipeline. It just won't let you.
Yeah.
You'll
At
get
all?
no. It won't make. It won't change. It will just return empty. And I feel like and also when I tried building my project, I started getting some errors and yields. It just won't work with the lightweight. But the lightweight render pipeline is made for especially the movement of more Unity mobile apps, as well as to help better work with whatever AR applications you try developing for phones or VR applications. As for that, even some, you have a very big game, you might want to convert it to a lightweight render pipeline for consoles. For example, the Switch may not be the most powerful, but it can help you there. But if you're making like a game that you'll know will probably work on like the PS4 Pro or Xbox One X or PC, it will probably be best to go with the HD render pipeline and take advantage of the graphical capabilities.
HD doesn't work on, like, isn't even supported for Switch and mobile or anything.
Oh.
You have to use their lightweight or standard if you want to target those.
It won't work at all on the Switch?
Nope.
Okay.
And they have no plans of targeting. It's because the HD uses the compute shaders a lot, and
Mhm.
there's not enough support for the Switch hardware.
Interesting.
Okay. So
Good to know.
Yeah.
don't convert. It's like right after Brett converts Mage Quit into like the
Right.
HD
That
render
almost happened.
pipeline.
He just spent 3 months going to HD. Now it's time
Yeah,
to switch.
converting all the shaders by hand.
So in theory, though, I haven't actually tried it, but you can choose which pipeline you're dealing with during
Oh,
runtime.
Sure.
So it would be really messy, I think, and difficult to set up in Unity right now. But you could target both.
Okay.
I feel like it'll cause like a lot of loading screens. So you probably leave your computer on overnight as it converts everything.
Yeah.
Right.
Well, so you can have the same assets in, but you'd want to probably like your symlink trick to like, okay, I want to open up
Yeah.
the lightweight version of this
Yeah.
project, and now the HD because the Unity editor itself only targets one at a time. But in code, you could target a specific pipeline when it starts up.
Okay.
So if you wanted to have a switch version of your project and an HD version of your project, you could have them in the same thing without having to like replicate Git repos and things like that.
Okay.
Well, the lightweight one breaks our water shader, so I'm not looking
Yeah.
at using either of them at this point.
Yeah.
Can you see this on camera? So it's not using either the lightweight or the HD render pipeline at the moment?
What, Mage Quit?
Yeah.
It's not using either one.
Okay.
Yeah, the lightweight is like the bare minimum to get a game going. And in theory, you can extend the functionality of the lightweight. You can edit these render pipelines.
Okay.
Oh wow.
But so standard Unity rendering is the middle ground right now. But then you don't get any of the shader graph or anything like
Yep.
that.
Okay. For the presentation today, I'll be using the lightweight render pipeline because I am working off my laptop right now. I haven't convinced an Uber driver to bring my whole tower over here just yet. I also came out of work, so. I believe this, yeah. I'll be leaving resources at the end where I got most of my information for all this, but we're actually gonna break it off into Unity. I'll show you some of the basic features that you can use. That's Discord. There we go. So we're just in a basic Unity project, and I'll quickly go over how you can make sure that these are in your scene. So if you were to open up Unity Hub or your Unity editor, there's already a preset file for this for either you want to do the, I think it's like 3D and then be in parentheses with lightweight render pipeline or the HD render pipelines. Or alternatively, if you have a project without it, this might show up as uninstalled only because I chose the package that has all of them in there, so I think that's why it may show up uninstalled. But if you don't have them, you need to go to your window up top, along with go to your package manager. And so in here, we're going to go a bit beyond shader graphs. There's a ton of preview packages that Unity is working on right now. And you can kind of consider these all betas, including shader graph itself. You might want to be hesitant if you have like a completed project converting to these methods, because it's all in beta and you don't want to risk really ruining your project at the moment. Because especially early on, I've experienced a lot of different bugs with some of the different Unity packages, just knowing it's not quite working right. But if you want to learn beforehand, a lot of them are pretty cool. Like 2D sprite shape is pretty cool, where it's this spline-based system for terrain to use sprites for. It's really cool, and it helps make your levels look very dynamic, despite just being like square sprites. It's really cool. Let's see what's here. Cinemachine is a really good one. I think Cinemachine used to cost some money right before Unity acquired it.
Yep.
Okay.
A lot of these do.
Yeah, like Cinemachine and also Prober ProGrids. These are applications that may cost like $100 or more even, some of them. But now Unity acquired them, you can have them for free, which is a really cool advantage. And even if you're a personal user, you can use all these preview packages.
What
So-
does Cinemachine do?
It's like camera movements.
Okay, it's sort of like for creating like cutscenes.
Yeah.
Yes, but you can use it for even more than that. Like you can use it for your actual game camera, which can create some cool effects like screen shake and things like that.
Oh, okay.
It would be really handy to just like trigger an event and then it starts in that.
Oh, okay, that's cool.
It'd be worth it.
So I use my twinning library for you.
Yeah, it does a lot of that, but it does it with like the built-in Unity curves and stuff like that.
Yeah.
It'd be worth the time to look into it.
Okay.
Anyone who's a bit more scripting savvy can take advantage of entities, which is Unity's new way of handling game objects as entities instead. It'll give you a lot more processing power to your game, but admittedly, the scripting can be kind of difficult to understand initially. Prober, ProGrids, and then you also have the post-processing pack. This will not work if you're using a lightweight render pipeline, so I can't really show off anything like that today.
Is that for just the HD?
It only works for HD. So what came out after the success and reception for the shader graphs is the visual affecting graph. It works practically the same way as shader graphs, but you're able to create this some really cool VFX art. It looks very high quality and might be better than Unreal. So.
But it only works for the HD.
Yeah, same applies. It looks really good, but it only applies for HD.
Yeah. It does have a little bit of a different interface, it's more of like a stack-based thing, but it
Mhm.
still has all the node-connected stuff.
So this is probably because I have a package running, but initially you just need what's here, the lightweight, or you just need either the lightweight or the high definition render pipeline right here. And then along that you'll need the render pipelines core, which is pretty much the engine for both the high definition and lightweight render pipelines. On the shader graph,
The lightweight is still in preview until 2019.1, but the HD render pipeline is supported in 2018.3.
it is?
Yep.
Okay. 2019 is still in beta, the build itself, right? Okay. So now if you want to start creating shaders for your scene here, I'm just gonna bring up just do whatever. So just right click in your scene and create, and then right here in shader. If you have it all properly installed, you'll now see PBR, physically based rendering graph, subgraph, or unlit graph. I'll get into what subgraphs are in a second, in a few moments, but we're gonna pick the physically based rendering graph. Again, these will not show up if you haven't installed it correctly, so we can call this game dev mi. It'll show up directly as a shader and a pretty cool. Oh, I wasn't done talking. We're gonna do that for a second. You can actually right click on it, and wherever it is here. You should be able to actually see the shader code. It would be like a jumbled mess, maybe not as organized, but you can see the raw Unity shader code inside whatever IDE you may have. I think so. It's weird.
You might actually have to compile it first before it'll, like the compiled code thing on the right, you might have
Okay.
to click that in the inspector.
Where is it?
Right there, yeah. I think you have to click
Oh,
that
there we
before
go.
it'll actually generate it.
Okay.
Are the shaders that this creates less efficient? It doesn't have to be wrote manually,
Yeah.
or is it negligible?
I would say it's negligible, but they are fairly well commented. They're big,
Okay.
but decently commented enough that you could find your way around to figure out where a bottleneck is.
Sure.
And
Okay.
manually tweak it if you have to.
Yeah, it will technically be slower, but again, negligible.
So if you change the code in there, does it mess up the graph then?
Yeah.
Okay, I would think so.
Could you import like texture files from Substance and stuff and work that in?
Yeah, you can. Yeah, you
So
can.
you
I think.
see how long it is.
Yeah, generated code.
Yeah, because it's all done by computer. It's again not efficient. So
I mean, it's all going to be compiled down. It's like C code-ish, kind of. I mean, they've got some like actual assembly code in here as
Oh,
well.
yeah.
So things are going to be already more optimized than you would have done it for some of the calls. So even if you mess it up, it's going to be about
Oh.
Yeah.
here.
Interesting.
and this is here to I guess somebody who already knows about shader code and everything. This is what it looks like to me, like any shader code. Okay.
Looks like a jumbled mess of
What was
letters
that?
and numbers. It looks like a jumbled mess of letters and numbers.
Yeah,
Like that pretty much.
just kind of like just went.
If you go all
Okay.
the way to the bottom, I think is where the main method is, right? Or these might even just be all of them, all the shader variants in one file. I think.
Maybe. Because does this look more similar? I'll go further down. Like I'm scrolling as fast as I can. It's not
Right,
even
I
making a
think
dent.
those are all the variants of that shader graph, so all the different kind of combinations you can have for different devices and everything.
Okay.
You might, yeah, 'cause that's the whole compiled, not like the editable version of it.
Okay. All right. So this is the initial. What you see initially when you open up a shader, it'll give up what would be the basic Unity standard shader. And over here is where, as long as you're working on here and add different variables, you'll be save these as properties. And instead of having to go all around, say like edit node over here, edit node over here, you can save them as properties, and this would be what's called your blackboard up here. You can edit any variables you want to save over here, and help you keep track of them. It used to be called a blackboard, but now it looks like they replaced the text with just shader graphs. So yeah, I'm kind of stealing a shader I've seen somebody else make. I'll show you how I did a basic glow effect for a spear here. So the way you move around is a bit different. You're not holding it in the middle mouse button or anything. You hold Alt, click, maybe to move around in your scene. And I actually find it, my best workflow for this is not use your mouse almost at all. Because all you need your mouse position, wherever your mouse is, you hold space. You're able to, you have the option to create a node, otherwise just right click, create node. So go here, space. And instead of like moving your mouse around and go to different channels, I find it easy just to use my directional keys and move around like this if I'm not already searching for something. So there's different via artistics where you have masks where you've seen some of the soldiers only had like almost like a jail bar thing where you see right through them. That'll help you done with masking if anyone's familiar with kind of the same way it works for programs like Adobe After Effects or Photoshop. Be able to blend different colors together. There's also like be able to multiply different colors today, and that's how we do a number of things I might show here today. Decide here how different textures might be used. So you want to make sure that texture is applied to any of these. You can put them in through here for the sample textures. Again, what I said, that if you have the knowledge of 3D math to begin with, this will help you a lot, because a lot of the ways you want shaders to move might be done through our math here. Different procedural things, and this will really go help if you want to say make something kind of like a low poly water shader. Is you could generate gradient noise, and whatever the scale is, I believe we'll just create that for you. It might take a second, but I think you already.
Like you have to flip the arrow.
Flip it.
There you go.
There we go. And you can have where it says, for example, you see the X10 over here for the scale, and also for UVs. You can do some of your math adjustments over here and have it be based off what you have, based off whatever calculations you want to put into it. So you also can access different time components. So over here, I find a sine time will loop back and forth for that effect, but you can have it just move as time goes on. So I would put this here, or the scale, sorry. It'll move on, you do something like this, which can be pretty neat. Then I can like do stuff like multiply this area as I go on as well. So I'm gonna delete this segment for now. I'm gonna create a node, I think it says first node effect, which is pretty much that. It's from outside in. What's a good way to describe this?
Kind of based off of normal.
Yeah. What was that?
Eyeball.
Eyeball. Okay, let's
Eyeball effect.
Which stack are you?
What?
I'm kidding. So one neat effect I've seen for especially to do a glowing shader and using this data you see here. So we actually can create another node. We can just put in a straight color here. And any takers for a color they want?
Purple.
Purple? Cool.
I lied, I want cyan.
Too late.
It's something like this, right? I don't remember what's.
Maybe a little more green than that. Yeah, like in there.
Close enough.
I love the stream just like broke down. Like people argue what cyan
That looks
is.
like the Streamlabs color.
What?
So that looks like the Streamlabs color.
Okay.
Good.
I don't use that.
Kevin wants chartreuse.
He wants what?
Chartreuse.
Chartreuse?
Color.
Salmon.
What's shark?
Speaking of Kevin,
Salmon?
wasn't he supposed to be here?
He said he was getting sick, so he's on the street.
I mean, I'm sick and I'm presenting. I don't want to throw shade
come
or
on,
anything.
Kevin.
Step it up.
All right. I think we just put us into the power here. Forget. Wait.
It's got more powerful. It's too powerful.
I forget exactly how to do it, but you can have the sign time come in here. I think maybe some maybe wrong, but I know this will go into a mission wherever effect you want your thing to give out. I haven't spent as much time on these as I would have wanted, I think. I think I'll put that where the normal is.
So one of the biggest advantages here already is the real-time preview of the nodes.
Mhm.
Like you do not get that when you're making
Yeah.
an actual shader.
Yeah, you only get what your what would be here, the PBR master. Once you save it, go back in Unity, see what this looks like. You don't get to see like I generate this noise grid. I can see what that looks like. Different color variables I add in. I'll probably just you had to go like to external applications to putting like extracting like RGBD codes off of that, as well as different effects. You won't really be able to see what this looks like.
You're telling me that when you don't see a hexadecimal number, you don't
Like,
imagine the color in your head?
Does that make sense?
Most of us don't.
It seems like it would.
Kind of, because if you have a normal map, you would apply.
Oh, okay, but straight up color.
Yeah, it doesn't make as much sense.
Okay.
So would he want to multiply it?
Yeah, he'd actually want to convert. So if you want the color width right for the Fresnel, he would reverse that. So Fresnel multiplied by color to then.
That's okay.
Okay. Oh yeah, I got the multiply here.
multiply,
Sorry.
yeah,
The Fresnel effect. Or Fresnel's?
It's for now, I think.
Yeah, it is Fresnel. It's like Quaternion. Who actually knows how to say it?
Yeah, how do you say
Quaternarian.
that? Is, oh,
It
okay.
is.
Yeah.
Quarter me
I used to call it Quater. I don't even remember how I used to say it.
I think I call it like
It's one of those things
Quaternine.
like, Hermione. Like,
Quater
who actually
deny-
called it Hermione?
Hermione, that's what that's when I first read the book. Hermione.
Yeah.
For sure.
So my mistake here is you need to be able to multiply these colors together and then bring into the emission PR masters, and you get this cool, neat effect of it going in and out, glowing around the outsides. You could probably what was that?
Pulsating.
Pulsating. That works too. It works better. It is really good for like probably lessen the intensity of it, but have it for like something that I can pick up effects. So actually, if I go in my Unity scene here, the basic scene, I applied it to the wood over here, and
It's dangerous wood.
yeah, it's scalding.
Oh, jeez.
It's like it's being forged.
Or maybe it's
So-
telling you to grab it or something.
Burn your hand.
Yes.
So I think I'm just gonna like, I hope I don't. If you were to right click something here, so let's just take the time you want to edit that.
You're looking for the subgraphing.
Not subgraph, not just yet. Oh yeah, so take the colors, probably be easier to edit than time. Can't really affect that, but you convert to property, and it'll bring it up here. So this is just something that's not really but you have to edit up here. So you have to
As a
go.
material.
Right.
Oh,
Just like you do like normal materials, like
Right.
the standard
Yeah,
shading
yeah.
change.
That's cool.
So it's kind of what would be your Unity inspector. Go right in here,
Yeah.
and yeah, we can make this whatever color we want now, which is very helpful.
Well, look at those hexadecimal numbers.
Okay.
Is that gradient noise being used yet? Or is that just hanging out there?
It's just hanging out. being affected by the cosine time. So it's
You
like,
gonna use it?
what's that?
You gonna use it?
Let's see.
It's wired up.
Being so efficient.
All right, so I'm gonna put the output. Wait, that was the position. So it's just moving out here.
You made a lightsaber.
Yeah, you can do some fun stuff in the position.
It's really cool to like mess around with, especially I guess for me, I don't really have much knowledge of 3D math, and just to like mess around, some crazy things will happen.
Mission. Whoa.
I had some problem. I think I tried to do something similar with the cutoff here, but let's not have this. Let's have the scale based on time.
There you go. That's cool.
I don't know what it looked like in the scene here. It'd probably be pretty blinding because how white it is, but
Yeah,
actually,
save. Yeah.
you gotta save it.
Go open
And-
up the material in the inspector. Like click
This
into
one here.
wood and show the. That's your game.
Yeah, use your scene to click on the wood.
Oh,
So
yeah.
yeah, so that's the shader, the subgraph. So actually, they talk about the materials first.
Yeah.
So he created a shader.
So our shader's here, and I've already applied it to our scene, but if you didn't do it already, you can't really create your own folders for them just yet. So whatever shaders you create with shader graph, you have to go to, then it'll automatically be put into this submenu here over shader graphs. But I was told or read that when this finally gets released, you better put them in your own folders.
I didn't even know you could do that. So the other way is when you create a new material, you drag the shader onto the material, and then it assigns the shader to that material, and then you can assign the material to other things. But anyway, so there's the color property that he created in
Yeah.
the shader though.
So like where you saw me, I added to the blackboard we have. Wherever properties we add to that, we'll be able to edit here in our material area.
So what are the rest of the properties on that material? Those seem like standard shader
Yeah.
properties?
Yep.
Mm.
Specific to the lightweight.
Oh, okay. The rendered cube.
Right.
Yeah. Whatever I add to the blackboard here is what I'll be able to tweak later in Unity.
Okay.
Which you also, it's not just this, you'll be able to create post-processing effects with this as well. I haven't dealt too much of that. You'll be able to do post-processing effects. Again, vertex manipulation. So I mentioned like with your noise graphs, and if you were to make a scale in its the position area, the generated noise, you got to create some pretty cool water shaders with it, at least for low poly. You raise the heights. There's a lot of resources and a lot of like really cool things. It's one thing that like I want to like show how you can get into and just have you play around and like learn just how deep this goes. Any questions so far?
Can you click on the shader graph and look at the inspector for it? The
What?
actual file.
Okay.
And then,
Oh, it's
stay there.
right here.
So if you look at the very bottom of the inspector, there's properties.
Mhm.
So that color B0CFA1A, whatever, you have to reference that specifically in code if you want to change the material.
That's the name.
in code, right? So it's not. So the name isn't actually the color. It's color underscore whatever.
Gotcha.
Can I edit it at all? Do you know?
I don't think.
Like,
so.
I can-
think it's generated.
I can give it like the main color property.
What- No, I don't believe so.
Okay. Oh wait, maybe I'm gonna try something here.
You might.
You
be
can
able-
rename them.
Right, but that name is only referenced for you here. But the generated ID, the
Oh.
referencing code is whatever the shader graph gives you.
Okay. Maybe.
So it seems like the going into the generated code thing is like not.
Yeah, you don't
Yeah.
want to do that if you don't have to. You'd have to be trying to like figure out performance bottlenecks to want
Yeah.
to get into it. But so each one of these nodes are things that you can create. So if you wanted some special effect that you can't do here, you could generate a custom node to have the ins and outs, and then
Oh, you could write like
Right.
shader code for that specific
Yes.
node. Oh, that's cool.
right.
Which
means
means
there's
you're
a-
playing with the other nodes already. Though.
Yeah, yeah, exactly.
That's
As
really
long as the types match, like vector 3 to
Yeah,
vector 3.
that's
then-
really cool.
Yeah, so it opens up a lot of possibilities.
Also, you could bring back whatever properties you created. Brian here. Almost like if they're prefabs. Oh, I didn't touch on subgraphs yet. So let's say you had this very complicated solution you had in shared graphs that you want to use for future shaders. Example, I think I just might touch on this, maybe. You can highlight wherever you need, right click, and convert to subgraph. This will almost be what a prefab is, and then you'll be able to bring this same utility you have here into future shader graphs that you have, which was another thing that would be super helpful. We had to create like, put all your properties in the same place and like control C, Control V, that wouldn't be too good. So you could then do here, would be brought into your assets menu, and just name wherever you want. Do sub. And then compile it into what it is here. It might simplify things a little bit, maybe. I had an issue a couple of times where if you simplify bind into a subgraph, it will just, I don't know, it will try to like render the things together almost, and I had some issues with just it bringing out nothing. But you do that here, and then, so I'm gonna make sure this project is saved now. If I go back into our failed shader earlier, I should be able to bring that in. Yep, we now have an area for subgraphs. Oh, you could bring in the whole shader. Oh wait, no. There we go. You could bring in that effect we had earlier. Okay. Anything else?
So how do you do this without the either render pipeline?
You can't yet until it. They said shared graph's going to be a normal part of Unity coming up here pretty soon, probably within the next year, hopefully.
Yes.
Shader graph will?
Yeah. I don't
But
know,
you
but
still have to use the render pipelines for it, probably.
So,
I don't know honestly.
so you could create there's a base shader that's out there that you can use that is the lightweight or the high def, and then you might the start of like all emptied out and just like apples and color. So then you could go and you could edit those. So you wouldn't have to use shader graph to create a shader for one of the pipelines. So, but using that
Wait, I
same,
want it the other way around.
right.
Okay.
So you can look at the code that this outputs, and
With that giant file.
no, that was the compiled down version. Let me see.
Okay, so this spits out like a Unity shader file.
Right. So if we
Feel free to
say,
hijack our people.
alright. Trying to remember.
Where are you trying to get to?
You could try show and explore and then have it
Yeah.
pop up in Visual Studio. There you go.
Hey, I don't have that program on my
Open it
computer.
with you.
Yeah, open it with the
That's I promise that's for a sound effect library.
That's not it either.
I forgot who it was, but I mean, I won't lie and say I never downloaded a movie before, but I promise.
Download a car.
I promise that.
What if I could?
I promise that one at
No,
least
I
was
guess I
for
would've downloaded
the
a
sound
car.
effect library.
You have a point.
It was like a bunch of sound effects artists giving out like they brought like this huge library. That was a
You're
compilation
getting
of
awfully
other work.
defensive about something that you're
Yeah.
gonna do.
I admit it. I have downloaded movies, but they gave it was like 20 gigs for their compilation. They're like, we don't want to have a site to host this, so you guys torrent it. Have it. Here's a torrent file. We'll seed it for a little bit, but it's up to you guys to keep it healthy from now on.
Are you seeding right now?
You know.
Boo.
I feel like Comcast will get mad at me either way, even if it is legal.
You guys gotta keep this live. No, not me. This is other people's problem.
I will use the files though.
Has anybody tried Unity Tiny?
Not yet.
Unity Tiny.
Yeah.
Yeah, it's
Yeah.
for extra small build sizes, and it like only uses TypeScript.
It like reduces the build down to like, what was it, like 8 megabytes for all of the Unity
Yeah, it's something
parts of
like
it?
that.
Yeah, it was like a
Wait,
teeny tiny
the-
cross section.
What do you mean by
Unity
TypeScript?
itself, or do you mean like
So
the build?
TypeScript is basically
Unity itself, the
JavaScript
Unity
with types.
engine for the tiny build reduces down to about 8 megs, and then the rest of it is whatever your game and assets are. Yeah, it was like
Is that for developing on the Raspberry Pi and for the Raspberry Pi?
Raspberry Pi was one of them.
It's still pretty much for mobile too.
Right.
That would have been
Yeah.
nice for Duet, because I think for Duet, our project, our EXEs or file size was like uncompressed 400 megabytes.
Yikes.
Yeah, I mean, even the lightweight render pack limit is often too much for a mobile app.
Oh.
Because, I mean, there's statistics based on like what your file size is versus people's willingness to download it.
Wait, is that 170,000 lines?
Yes. And so this is all of the different variants. So I downloaded 560 something shader
I don't know
variants.
exactly.
I don't remember how. I thought for sure you could see the code for
I
this.
mean, it would largely depend on like, are you doing 2D versus 3D? Just
Maybe
how
not.
expansive is your game in the first place? How compressed are the assets you have?
Maybe I was wrong.
I remember hearing what you were talking about though once, but
I'm coming at it from someone who hasn't.
I've also heard people say that like it's just a jumbled mess.
Since
Yeah, I mean, this kind of is.
So
The
yeah,
compiled
it's-
output
Probably
is.
came up before.
So you've never used Unity?
No, last time I extensively used
Why?
Unity was
It must be
Why do you
not.
say you hate it?
I hate everything.
You don't. That's his thing.
Yeah.
Yeah.
You have anything you want to show? Shader graph?
So what'd you find?
I think the compiled output here is all you can really get to.
Okay.
But is it cool if I use Chrome?
Wait. Shit.
Turn it off, quick.
Get some rice.
Did I pour?
How do you always spill?
Did I pour soda on my computer last time?
No, it was your phone. You
That's
poured it
right.
on your phone last time.
Luckily, it's just water.
You should try turn it
You just turned it off.
Yeah, I did.
Just leave it off.
It's on sleep.
The stream's over.
Who spilled?
It's me. I was gonna grab my computer for a sec.
It was my fault. I was in the way.
Alright. You wanna use your computer?
Sure.
So if you can't get code out of the shader graph itself, you could at least experiment with it, and then you could have an idea of how you wanted to create that effect in code. Okay. As I'm just trying to figure out how we could still use that.
I just hate that was not all done on camera.
Apparently I lost.
What's that dude saying in the chat?
Kevin?
Wait. What's chat saying about it?
Oh, I missed it. It was like BRB.
Capture things? I'm gonna have to unplay it and put it back in or something. Yeah.
You wouldn't download car? Heck yeah, I would.
Is that an Elgato?
It is an Elgato.
I love Elgatos.
What's the ASM codes in
Well,
reference
so I
to?
have to steal that Elgato. So you can't use it.
ASM codes for 500, Alex.
The one person who
Oh,
gets
so
whatever
maybe
is
for the
represented.
shader that we were looking at.
Oh.
Okay, so
How many people are watching?
3.
3 people.
Well-
So popular.
This trade, right?
So 2 plus
2.
Garrett having it open on his computer.
Right.
We're so popular.
I'm sorry I wasted some of your pooply.
So this is what shader typically looks like for Unity. And so you specify
Zoom in.
properties like this. So this is a
Control
lightweight
plus.
render pipeline shader, like a raw file. that
It's
you can
very
then
tiny.
Control plus.
Control plus.
Thank you.
There we go.
I can read some of that.
I know some of these words.
Yeah.
Base map.
Yes. So yeah, this is 2D, so a color range. So it's kind of a, so there's
These are all inputs, yeah? Or no?
yes,
Just variables?
these are properties, so things that
Okay.
you would set from the editor.
Okay.
So Unity would pick these up. So this is Unity's shader language thing, but this then gets compiled down into HLSL or GLSL or Vulkan, and then that then gets compiled down into the actual shader code that is then run on the graphics card.
Okay.
So this is a level up, which is nice because there's a lot of, if they didn't do their own
You'd have to
language, you'd
write.
have to write multiple shaders.
Mm.
But doing this, there's some goofiness like this, hide an inspector, so you couldn't just like copy paste this into HLSL and then expect for it to just compile. There'd be some work to do to try to do that. And some of these things like the equals 0 here, where it tries to default to a value, that's not a thing in shader code. That's a Unity shader thing,
Right.
where when it compiles this down into the other languages, it'll automatically set.
These shaders are usually stateless, right?
Yes. Yep, so, yeah, if you guys probably, has anybody written a shader here,
Learning.
learning?
I hated it
Okay.
and stopped.
Okay, so maybe you guys want me to go over
Yeah.
that far?
Yeah.
Sure.
Okay. Okay, so in Unity, well actually, okay, in any 3D program, there's a rendered pipeline, not like the scriptable render pipeline that we're talking about, but a pipeline that goes through the graphics card. So the vertex shader is the first one that you're gonna hit. And so that, when you render out just even a triangle, you're rendering each point through the vertex shader. And then as long as it's a simple one, you've got a vertex shader and then a pixel shader or a fragment shader, depending on which one you're talking about. HLSL tends to refer to it as a pixel shader, whereas GLSL says it's a fragment shader. And technically there's differences between them. Or between what a pixel is and what a fragment is. But that all renders through. So once you do the vertex shader and you create your 3 points, so that clockwise versus counterclockwise rotation matters at that point, because that's what's going to determine whether or not the triangle is called out from the video card. And then at that point, it sends that data down to the pixel shader. And so then the pixel shader goes point by point and runs through everything. So really your shader code, especially in the pixel shader, which is important, is running your same program on every single pixel that it touches. Which is why, like, when you talk about MSAA, like subsampling stuff, when you look at a single pixel and you want to do 4x MSAA or 8x or 16x, it's running and it's looking at one pixel and then looking at all those surrounding pixels for every single pixel, which gets, when it has to do that many texture lookups, that's why it gets so bogged down. But then there's, let's see if I can find,
Your phone was ringing, by the way.
oh, does somebody need in?
So did he just say that the shader applies to that last step where it's actually painting the pixels?
Yeah, so the pixel shader is the last step.
Wait a minute.
Oh, James called him.
Call him on stream.
What can you tell us about shaders?
Shaders.
Garrett, did you ever do a, because you had OP engine, did you only do that in OpenGL, or did you ever like, I'm gonna Vulkan this?
So in the OP engine, I wrote in GLSL, but then I used the Vulkan converter stuff to convert GLSL into Vulkan code. And then the Vulkan code got converted into a GPU intermediate language that then would convert into whatever I wanted, so GLSL or HLSL or Vulkan. Yeah. It's a complicated process.
That's why I switched to Unity.
Okay, so vertex shaders first, then geometry shaders. So geometry is, so once it goes through the vertex shader, you can actually add additional vertices with the geometry shader, which is cool because like you could do like particle systems, for example. Rather than uploading like a whole bunch of spheres to your GPU and saying, I want all of these rendered, instead you could render or send your vertex shader 1 point, 1 vector 3, and then your geometry shader like could generate a sphere from that 1 point where it was at. And then your tessellation shader is adding geometry to, but it's more, rather than like creating a geometry, it's adding detail.
Okay.
So you could,
map.
right, so kind of like a height map.
Height map,
would be
okay.
more
Yeah.
accurate. So you could specify a quad, for example, which would just be the 2 triangles. Then in your geometry shader, actually that one you wouldn't have to do anything, but then in your tessellation map, you could add additional vertice points to that with a normal map or height map that would adjust that, all with using just a quad that you'd have to send to the GPU.
That's cool.
So when you're doing rendering, when you have to send data from the CPU to the GPU, you want to limit that as much as possible, which is why you'd want to do points and why you'd want to use a geometry shader rather than generating all that data and sending that giant buffer to the GPU, because there's a lot of time that's spent there, especially if it has to be done every single frame. And so then, yeah, all these things, there's compute shaders and stuff like that, but that doesn't really involve like a GPU rendered frame. Compute stuff is only for mass parallelization stuff. And then that all goes down to the pixel shader, and then the pixel shader dubs it straight to the GPU. Or to the display, sort of. There's still like buffers and stuff like that, so double buffering, triple buffering, and all that works. Yeah,
Does that TV have an adaptive brightness?
probably.
Yeah, that was obnoxious.
I was losing it, man.
Yeah, you gotta make it.
Ooh, extremeception.
Let's see if I can go back. So if you look at this shader again, so some of the things like the call mode, so right now it just defaults to the call property, which is probably up here somewhere. So the calling is that counterclockwise versus clockwise triangle, and so you can turn it to forward clockwise calling or counterclockwise calling or just no calling, meaning that if your triangle goes either side, it'll still render it if you don't do the calling.
Just switch brightness again.
This is a little bit more HLSL focused. So GLSL does not have the idea of passes quite like HLSL does. So in this, you would specify multiple passes, almost like functional programming, where it goes pass 0, process my vertex data, pass 1, process this vertex data, and pass 3, process it again, and then pass it all to the pixel shader, or it's pass 4 or something. But in essence, it's just kind of like calling a function and then calling the next function. It's just a way to separate data. But then you could turn passes on and off, was the idea behind it. So if you like for a height map, if you wanted it to all be flat and then pass 1 would actually raise it, you could just turn pass 1 off if you wanted to keep it flat, but without actually having to recreate a brand new shader. A fun fact about shaders is that when they are sent to the GPU, they are compiled at runtime on the GPU to be then run. So you don't actually compile, not like when you're creating an executable for a machine for your final deliverable, the shader code itself is actually given and then passed to the GPU, and the GPU compiles it during runtime and then runs it.
Weird.
Is that because the GPU has its own special custom optimizer?
It's mostly because it'd be next to impossible for game devs to keep up with all the GPU drivers and fragmentation, that rather than trying to build towards a specific spec, it allows the GPU vendors to then do their own thing, which is also a nightmare because there's, like, even between different, like, NVIDIA GPUs, there's differences on how a shader can compile down and run. But the vendors liked it because now NVIDIA can dump a whole bunch of money and say, hey, now look at that, now we have MSA X16, whereas AMD doesn't, because we were able to just turn a flag on and now we support extra stuff for their games. And that's why you get like the GeForce driver stuff where they'll like optimize your games, because they're going in when you start up the game, the shader code that's passed, they'll start replacing chunks of it because the NVIDIA team will have optimized sections of that game's shader.
Interesting.
Yeah.
I don't think they'll do that for any of my games.
Right. Well, so it kind of benefits everybody a little bit, sort of, but it was still a nightmare. It's kind of like Android phones. Not so much anymore, but because there was so much fragmentation, you build one app. Okay, now I've got to test it on 500 different devices because who knows which one is actually going to break it. So that's why Vulkan started becoming a thing. Vulkan, Metal, and DirectX 12. Because now you're no longer dealing with the drivers that they supply you with. They're building a spec, and then you are the one managing the driver. So it makes the devs work a lot harder up front, but it also makes everything a lot faster because you know exactly what you're asking for. Whereas like DirectX 11 and 10 and all that, they had to do a whole bunch more checks because they had no idea what you were going to do. You could have done anything with the data. And so now you can be like, all I'm doing is rendering a mesh. I don't need to check for post-processing, I don't need to do any of this jazz. So that's why you get like 2x speed up sometimes with game development.
What's all that Pragma stuff?
They're
Compile
multi-compile. It's all Unity, shader, magic.
Okay,
Yeah, lightweight pipeline keywords.
gotcha.
So this is kind of including functionality into the shader that it should have.
Gotcha.
So this one is specifically for the lightweight render pipeline and
I see.
stuff. So that's why you don't see a whole lot of extra stuff. So actually HLSL program. So yeah, so you can see that it's directly targeting HLSL, but then see required to compile GLS 2.0. So that's what this is. Oh, that's interesting. So this doesn't even include DirectX 11 and through 9. So they're only targeting D3D 12, DirectX 12, which is like the Vulkan or Metal equivalent, which is cool.
Is there a reason to target 10 or 11?
Only for your own sanity if you were developing your own engine for it. Because
And accessibility awards.
Right. If you were building an engine from scratch today, you would want to target DirectX 12, Vulkan, or Metal. You wouldn't want to bother with anything below it. Or you can just use Unity and be a script kiddie and just drag and drop because they've already done all the work for you.
Hey.
Yeah. That's about it. Is there any questions with it?
What does that shader do?
This one doesn't do like anything.
After all that.
Yeah, this one I think is specifically for the particles. Yeah, particle simple light shader.
Oh, okay.
So this is coming from the render,
Gotcha.
the actual Unity's pipeline for that one.
Okay.
But we could look at a more complicated one, like. Actually, let's go back.
That shader's lit.
Yeah. So subshader, pass, HLSL program, blah blah blah. Fog. That one's only like including stuff. And there's like no direct data in. These are all just including files.
Hmm.
Lit input. Okay, so this one gets a little bit more. So this is a half 4. So now, so it's still a.
So it's like 2.
It's like a vector 4, but using floats that are tinier. That
Oh,
are
okay,
half the size.
gotcha,
So they're
gotcha.
using 16-bit floats rather than 32-bit
Okay.
floats. Which is good for gloss and stuff like that because you're never going to notice the difference between a millionth of a percentage for how specular something is.
Hmm.
With shader stuff, so HLSL does the same thing as GLSL, where it's called swizzling.
You just made that up.
So the spec gloss, you could access it like that, or you could access it like an array. You could access 0 for the first one, or
Restart
so like
on.
so this A RGBA. So this would be spec gloss bracket 3, and that would access the same one. Or specifying it by A gets you to the same position,
Gotcha.
or specifying Z would also get you to the same position, because X, Y, or W,
W.
X, Y, Z, W
Okay.
is the same thing
Yeah.
as RGBA, which
Yeah.
is the same thing as array
0
index.
through 3. Okay.
But, so this is returning one float value, whereas RGB is returning a float 3,
Okay.
which they're not, I guess technically they're not vector 3s in shaders, they're float 3s.
Metallic RRR, does that return the same thing 3 times?
Yes.
Okay.
Yep.
Float
So,
3 is
which makes
really
sense for
nice.
metallic, because when you're uploading a metallic texture map, then it would usually be metallic roughness specular or something, metallic
Okay.
roughness occlusion. So when you're doing the texture lookup, you're getting the 0 to 1 value from the texture, but then you want to multiply that across the entire color, so it's that one value of the metallic amount 3
Gotcha.
times to evenly multiply it. Sample texture stuff, that's actually a lot more complex than it makes that look. Like, so this is a method that they got some util somewhere that does the texture lookup stuff. But there's a lot of, I bet you there's 100 different ways to do the texture 2D sampling. Because when you do a texture, you're creating a sample of a specific position. And that could be complicated by whether or not you do like anisotropic, how do you actually say that, anisotropy, something?
Innistrad.
Yeah.
Anisotropic.
There we go, his version of it. So if you've got that turned on, then it'll actually like subsample the pixels around it, versus if you've got linear filtering, then it will pick the exact position. It'll like do a math.floor to figure out the exact value. And then it gets even more complicated when you do like mag filter versus min filter. So if you do, like if you had a 512 by 512 texture, that you then did the min and filter stuff, so then it would reduce it down to a 256 and a 128 and a 64 or 32
Oh,
or
okay.
16. So depending on how far away you were sampling the texture from, it would choose which level
one to give you?
to sample it from.
That's mid-mapping?
Yeah.
Okay.
So this one, it looks like it's just doing a standard texture 2D sample from the occlusion map based on the UV coordinates of whatever was passed in to the model. But it all depends on how the occlusion map was set up for the texture 2D and whether it's got the anisotropy.
Anisotropic.
Yep.
Is that a smoothie?
Huh?
Nothing.
Smoothie?
What do you
So-
got there?
So these are the actual like pics. Well, so this is the vertex shader output. So when you specify, so the vertex shader and the pixel shader are two separate parts of the same program. So this is another reason why you compile code on the GPU, because you can mix and match vertex shaders and pixel shaders with other ones. So it's kind of like creating your .cs file and slapping the vertex shader on the top and then slapping your pixel shader on the bottom and then compiling that one file into one shader. And then it can output. So your vertex shader has your inputs. So that would be your vertices, your texture maps, your UV coordinates, tangents, normals, all that kind of data that would come from a model that goes in would be passed into your vertex shader, and then your vertex shader has to have an output, which can be a user-defined struct of some sort. But then that struct, which in this case is the out surface data, then gets passed into the pixel shader. And so then the pixel shader, this output, actually I think it's the pixel shader that would define it, determines whether or not it's how that value gets brought into the pixel shader. So it will interpolate if you want it to. So for example, a normal, if you were doing if you did a quad and you had the normal and it pointed in that direction on one vertex and it pointed that direction on the other, if you were doing your pixel shader, you would want that normal to possibly interpolate between the two, rather than being a hard snap, okay, the normal's here, and then as soon as it gets close enough to the other pixel, it snaps over to this one.
That'd be how you do like a cell shader.
Yeah, probably. And so that's all defined on the pixel shader input, on whether or not it does that. And in GLS, like I know you're doing that, it's called a varying value.
Right.
Inputs, maybe it's just in the forward pass here. Yeah, variance right here. Weights, see how it specifies it. So it's passing these varyings, so this struct up here, right here. So this variance is what the vertex shader is outputting. So that's what these normals and all that are setting. And then it's all fragmented. So this is what gets output as a pixel, the pixel shader. So color, in this case, color is the only thing that is being exported, or is the output of the fragment shader. But for the example of deferred rendering, for example, would have multiple colors because it would be outputting to multiple textures all at once. So which is called a G buffer in deferred rendering. So when you do a deferred render pixel shader and you render this model, it renders out to all four of these at once. So rather than outputting just one color, it outputs four colors that all define what those textures end up being. Which is the only reason that deferred rendering is even as performant as it is. Because otherwise you would have to re-render that 4 different times for the same model to get this value right. So with deferred rendering, you've got your first pass is render your model out. So rendering these models to 4 different textures or however many textures in each G-buffer. You then have another pass that you render your lights out into a whole different texture. And then you've got your final pass where it sends all 4 of these textures and your light texture into one full vertex and pixel shader pass, which then samples from all of them to decide what that final pixel value is. And for that final pass, it's just all it is rendering one big quad to the screen. That way it can sample these and render them all out. Actually, this is a better picture of it. So when this scene, this was it Sponza, something like that. That's the name of the model. It renders the color value, then the specular, then the normals of everything, the depth, and then when the pixel shader gets it, it receives all 4 of these textures. Then samples on each pixel sample from each of these at the same position to figure out what that data is, and then spit out the values. The only downside to this is you can't do transparency with deferred rendering unless you did like layered rendering of deferred render stuff. But then this gets complicated because you start getting a lot of video memory issues, which isn't as big of an issue as it used to be a decade ago. Because now 16 gig for your video card is not uncommon, which is crazy. But with this, like if you think about a 4K texture, because it's all uncompressed in the video card, it's huge. And then when you have to have 4 of them, they are all sampling from for 4K. That's a lot of data. Exactly. And then if you were to do layered deferred rendering to get the benefits of transparency, like for each additional deferred rendering layer, you could have 1 level of transparency. But usually what ends up happening for transparency is you'll do your deferred render pass, and then you'll do a forward render pass on top of that using the same depth buffer when you render the models on top of it.
What would be the point of the transparency if you wanted to be able to see through like a certain mesh? Or
Like
something?
a glass window.
Oh,
Like a
just even
storefront.
something like that?
Yeah.
Oh.
Yeah, because in this case, if you were to do a glass window right here, you would go plop, okay, now that's all covered up. And now how do you do the texture data for anything below that point? Because then all of a sudden your normals are all covered up by this glass pane because the glass pane's got the normals pointing out. So it just kind of renders over top of everything. So unless you were to do like 2 different normals, one with this, and then another one with a transparency one that had another set of normals, then you could sample from the same point and get the same data. Exactly. So that's why you usually end up with multiple. You get the deferred render pass and then the forward render pass on top of that for that. But that's got its own trade-offs too, because then you've got to figure out how to do the same correct lighting for the forward pass that you do for the deferred one. Which the whole point of doing deferred rendering is for the crazy amount of lights that you can have. Because with lighting, you've got another texture, a lighting texture pass that has all of the lighting, and all it is just however many draw calls you want to make to that lighting pass, and then it's just per pixel lighting. Whereas normally, if you were to do like thousands of lights, it would be sampling thousands of lights per every single pixel, instead of just 1 to 1.
Yeah.
Which I wonder if it's probably got light heat map, just kind of sort of right. I don't know if this has got.
This would be for dynamic lights? Or no?
I mean both. You
Okay.
can do static lights with a deferred render too. It just acts like a. So.
So which of those buffers does it change if you have baked lighting?
If you change, in that case, you would just pass in an additional texture.
Oh, you'd have one more that's just lights.
Right. Yeah,
Gotcha.
just the static lights that
Okay.
you would sample from. Diffuse buffer. So this isn't that far off from a typical G buffer, so that's what it's called for deferred rendering. The G buffer is a set of textures that
Okay,
you're
yeah, I see
rendering
it
to.
there.
And so and they're all going to end up being RGBA, and then the magic is figuring out how to fit everything into as few points as you can. For example, this right here, the normal, this is the worst way you can actually store a normal for a G buffer, because with normals they're always a length of 1, which means that you can actually specify just 2 values, get rid of the third, and then on the fly figure out what that last one is, because you know the length is always going to be 1, so you can figure that out. And then with a normal, you don't have a W, so you just get rid of that. So already you're down to just 2 float values instead of these 2, which means that you can potentially fit these, for example, into the specular, because specular is only going to need 1 float value. So boom, you can do that. And then diffuse, you're not going to need the alpha. So already we can get rid of like 6 different floats there. 7, because you don't need light accumulation, is not going to have an alpha. And then there's more magic. You can even do that. In theory, you could get a normal to fit into 1 float, but you have to the fallback there is how precise it is. So you lose precision by doing that. Still trying to find a light buffer. Although maybe, okay, so technically you don't have to do a light buffer, I don't think. I'm trying to remember. I think you can render out the scene. So like this is an example of like a typical deferred render sample you'd see, where it's just like crazy amounts of lights everywhere. But in theory, you can render out the whole scene with the data without lighting, and then make another pass that has a directional light, so it goes over the entire scene with the direction light, and then you render. So each one of these are actually just sphere models that are rendered.
Oh.
They're not like, so you could like for spotlights, point lights, you can render an actual cone. So that's all it is, just a cone model that you render, and poof. So then when it's rendering, so it renders that sphere, then at that point you sample in screen space to figure out where on that texture you're sampling from, to then figure out what the normals and color values are, and then just kind of superimpose that onto the scene. And so
Does it figure out collisions based off of the depth
Nope.
buffer then?
Well, yeah.
Okay.
For depth buffer. So yeah, when you're like, if you were to do a big sphere right in the very center, it would do a depth check to see if it was able to get far enough, and if
And
it
it might
wasn't,
not do anything.
right, exactly. But it makes it really cheap to do lighting,
Yeah.
because then at that point, all it is just rendering a sphere, render another cone.
Yeah.
Directional lights are the most expensive, because that has to be scene
Everything.
wide, so you're touching every single pixel instead of just like this subsection of pixels for that light.
That's cool.
And then you do attenuation just by how far from the center of your sphere you are, so that you can get smoother lighting. I got a little off topic.
How much do you play with shaders to find out new toys? to play with?
I don't as much anymore.
He just drags and drops now.
I do.
Sounds
I
good.
am a sad script kiddie now.
Sounds like you miss it though.
So I used to play around with it quite a bit, and actually I had this one. This was a fun one. So I worked on my own cross-platform engine for a while, so this is using physically based rendering. So this is all GLSL code, all custom done and everything to get this all working. So it's using environmental, like the surrounding scene as the lighting. So you can kind of see, especially around the gun here, as it changes scenes, you can see the
Yeah.
color It's
So
breathing.
it's using HDRI lights.
It is, yeah. Which that was a nightmare too, because it's with the HDRI images, they're really just big, long, like equilateral. I don't know what the term for that is, but really big, long images. But it's a full 360 image.
Okay.
But in order to get that into the image or into a shader to be able to sample it correctly, it has to be turned into a cube map.
Oh.
And then you can sample from to figure out the direction for the lighting. So that was a process in itself.
Do you watch a lot of Linus Tech Tips?
I've seen it.
Just check out your YouTube recommendations. You got your No Clip documentary, you got your Linus Tech Tips,
Yeah.
you got your Miley Cyrus.
Oh yeah.
I'm starting to get like an overwhelming amount of Norm Macdonald in my recommendeds now.
Did you watch a lot of Norm Macdonald?
I watched like one video, I think, where he made a moth joke on Conan, and ever since then, my the recommended videos on the side panel of a video has always been like maybe 2 or 3 Norm Macdonald videos. Where like Norm
You must have
Macdonald.
laughed really hard at it.
Yeah.
They heard you in the microphone.
Yeah. Yes.
So like it's always like titles like so and so Savage Roast compilation or like
Oh no.
stuff like that. I'm like I don't even know.
It's a pretty good like percentage you got there. 100%.
One. I did that. Actually, I've got I have a deferred render video of that Sponza model, I think. Where's that?
One year in prison. What? What is the video?
Is it a documentary?
Of my
Could be.
right there. Deferred SSAO. So this is that same model. So this is a deferred render that I did for the LP engine.
Oh, cool.
So this toggles between position, normal, specular maps. So these are all textures that get sent to the GPU, and so that was a big light thing. SSAO is another beast of a thing. So that's
When it
showing.
goes into depth.
What's that?
Except when it goes into depth,
Yeah.
it just turns into Silent Hill.
Oh yeah.
So now that you know all this stuff and you've actually played with it, are you able to like, when you do you play games,
Yeah.
are you able to like optimize it pretty well in the settings?
Oh, I just turn everything out.
Yeah.
Just max it out. If it doesn't work, then I'll figure it out.
Cool.
I haven't had that issue yet. But yeah, in theory, like so MSAA stuff used to be the biggest drain on things, but even that, as soon as like NVIDIA sees that kind of code in a shader, they'll go through and vendor specifically optimize that out, and they've got hardware stuff that will optimize that flow, so it's not subsampling every time for every pixel. It says, okay, I need to do this, so just spit that process off and done. So that's how some of the things that they'll do to
I remember like back in like 2012, 2013, yeah, you turn on like MSAA, even like two samples, like it'll cut your frame rate in half sometimes.
Yep. Yeah, and it's exponentially worse.
So it sounds like each video card is now its own secret sauce.
Pretty
That,
much.
like, there's no, they're incomparable. You can't be like,
Yes.
I mean, you can't, I guess you can be like, this one is definitely like outperforming on this one because like this $100 more obviously is.
Right. Yes.
Like,
It's more so vendor specifically. Like
right.
games on the NVIDIA stuff are typically going to end up running better than the AMD counterpart because NVIDIA spends so much money investing into that because gamers are such a core of their business. Whereas AMD hasn't put as much resources in because they're not as big as NVIDIA either.
Yeah. And they get a bunch of people coached by Intel.
Right. Yeah, because Intel's coming
Intel's
out with
making
their
graphics cards in like a year.
But they're gonna have a dedicated one soon. Next year, I think.
Intel?
Yeah, that's what
Yeah.
it is. So
Yeah, like
I think they're gonna have a dedicated one soon.
yeah.
Yeah, they made a dedicated one like what in the late '90s,
Yeah, it's been
and
a
it
while.
kind of flopped. And so then we started doing the integrated stuff, and that's been doing well enough that now they're going to come back.
Take another stab at it.
Right.
I've been doing great with my Intel HD graphics 3000.
Yeah.
I had an issue where whenever I hooked my computer up to a TV and tried to run my game, it ran like garbage. And then I finally realized it was running off of my integrated graphics card instead of mine. And I found it out because of SR Debugger.
Oh, really?
Yeah, I went to report a bug for something else, and then I like happened to notice in the specs that it said my integrated graphics card was the one that was being used, and I was like, well, no wonder.
SR Debugger is awesome.
Yeah, it's pretty sweet.
Anything else you guys want to know? Just want to just chill and hang out?
Sure.
Okay.
I say let's work on things.
Work.
Yeah, isn't this supposed to be a let's work on
Yeah.
things?
What-
I
what
guess
work on?
Let's listen to Garrett talk about
Yeah.
things.
Does anybody want to have anything they want to show off? Any project status? Any videos? Anything? Floor is open. No.
We're all too embarrassed.
Okay. Everybody go review Brett's game.
If you want to quit.
Thumbs down.
I'm trying to get either sued or hired by Respawn.
Pardon?
Oh,
He loves battle royales.
all right.
No, I'm trying to make a controller similar to Titanfall